Hey folks, this is Mr. Moray coming to you with a little video on absolute value word problems, okay? So in this video, I'm going to talk to you about how to solve absolute value word problems, both containing equations with absolute value and inequalities with absolute value, okay? So first I'm going to start with the equations, and then I'm going to do the inequalities. Okay, so the important thing is you need to first read through the problem. You need to determine, is it something that has to do with an inequality, or is it something that has to do with an equation? Then you have to write the appropriate equation or inequality, and then you have to solve it. Notice in this first sheet, I don't clearly say what type of problem it is. So let's take a look. All right, I'll do a couple examples, and of course, there'll be ones for you to try as well. All right, a machine is used to fill each of several bags with 16 ounces of sugar. After the bags are filled, another machine weighs them. If the bag weighs 0.3 ounces more or less than the desired weight, the bag is rejected. Write this equation to find the heaviest and lightest bag the machine will approve. We could actually look at this as an equation or an inequality, okay? I'll show you an equation because this one asks us for an equation. So what we have is we have our absolute value, and this is my equation. Now what it's saying is we need to look at the difference. So this is what we have. So what it means is the difference between the amount of candy in the bag, or sugar I guess, and 16, right, can be no more than 0.3, okay? So usually we learned absolute value means distance from 0. But if you put in a number inside like this, this means the distance from whatever A is. So this would be a positive A, and this would be a negative A, okay? So this means distance from 0, because if you think about it, if A is 0, all you have is X, and this is distance from a certain number, all right? So what we're looking for is the difference or the distance from 16 has got to be equal to 0.3. Okay, as an inequality, you could look at it like this. The difference between the weight of the sugar and 16 can be no more than 0.3, meaning it could be equal to 0.3, it could be less than 0.3. Okay, so remember, in order to be able to solve the problem, you have to have an understanding of how to solve absolute value equations or inequalities. That was talked about previously, and so if that's something you're still struggling with, it's something you really need to get a grasp on, because if you can't solve the equations or the inequalities, then you can't solve the word problems that involve the equations or the inequalities. So the first thing we do is we look at this. Again, we ask, are the bars alone? In this case, they are. So that means either x minus 16 is equal to 0.3 or x minus 16 is equal to negative 0.3. And then to solve it, I add 16 to both sides. So that gives me x is equal to 16.3. And this one, x is equal to 15.7. So that means the lowest it can weigh, okay, is 15.7. The highest it can weigh is 16.3. The inequality actually gives you a sense of the actual range of acceptable values. So here, if we split it, because the bars are alone, I get x minus 16 is less than 0.3, or x minus 16 is greater than or equal to negative 0.3. And then when I add the 16 on both sides, okay, I get less than or equal to 16.3 and greater than or equal to 15.7. So what I get is 15.7 is less than or equal to x, which is less than or equal to 16.3. Okay, it's an and inequality because there's a range of potential values. Generally, most of the time, if there is an inequality, it will result in an and, but you have to read the problem to know whether that's true. Okay, so there's two different kinds of problems we could make out. In this case, it specifically asks for an equation to give me the highest and the lowest. And the highest is 16.3 rather, and the lowest is 15.7. If it asks what is the acceptable range of weights of the bags of sugar, this is a range of values. So this tells us that the machine will accept any bag that's at least 15.7, but no more than 16.3. Okay, so again, I encourage you to kind of rewind. If this was something that was tough for you, rewind and take another look at it. And then in a second, I'm going to move on to the next problem. All right, let's take a look at the next problem. The average number of seeds in a package of cucumber seed is 25. And sorry, I'm just going to block this off just so we can focus on the current problem. The average number of seeds in a package of cucumber seed is 25. The number of seeds in the package can vary by 3. What are the maximum and minimum number of seeds that could be in a package? So what I want you to do, take a second, think about what information should be underlined. Once you figure that out, unpause the video, and then I'll underline this one for you. All right, cool. So what I want you to do is let's take a look. So what we know, the average number is 25. Okay, can vary by 3. What are the maximum minimum number? We could look at this either way. It says the maximum minimum, that implies an equation, whereas what are the acceptable number of seeds, or what is the range of acceptable number of seeds that can be in a package, would imply an inequality. What I would say is that on a test or a quiz, I will be more clear as to which one you're going to use. But if not, you should look for keywords like equation or inequality, me telling you specifically what to use. Okay? So the maximum number, so what this means, can vary by 3. So let's set up our thing, our bars, let's make it equals. So what that means is the difference between the number of seeds that are actually in the package and the number of seeds that are supposed to be in the package has to be 3. In theory, no more than 3, because we want the maximum and minimum that's going to occur at the endpoints, right? So the difference could be 2, the difference could be 1, it could be none, like there could be exactly 25 seeds, okay? Or there could be 3 more. But for example, there couldn't be 29 because that would be 4 more seeds, okay? So let's look at the max and the min. So we split it, the bars are alone. So x minus 25 is either equal to 3 or x minus 25 is equal to negative 3. And then we add 25 on both sides. We get 28, which is the max. We get 22, which is the min, okay? So this is how we solve these ones. We set it up. So when you see vary by versus here, it's telling you what's supposed to be in there. That's why we're putting the 25 in there, because there's supposed to be this much. This describes the variance of 3, meaning the difference equaling 3, right? This is what the difference is equal to. This is the difference itself. Okay, so if you need another moment to really go through it and kind of walk through it again, I encourage you to do that. Otherwise, in a second, I'm going to move on to the next problem. All right, let's look at the third problem. The mean distance of the Earth from the Sun is 93 million miles. The distance varies by 1.6 million miles. What are the maximum and minimum distances of the Earth from the Sun? Okay, so here's what I want you to do. I want you to take a second. I want you to pause the video, try to solve the problem, and then in a minute, unpause, and I'll show you how to solve it. All right, here we go. So the distance is 93 million miles. Notice the word varies by 1.6. So what that means is the 1.6 is what it's equal to. That's the variance. the distance, you can call it whatever letter you want. You call it D for distance, as long as it's not like one of those forbidden letters like O or L that look like, 0 or 1. And then what I'm going to do is, okay, so the mean distance of the Earth is 93 million miles, so that's the distance. It can vary by this much. Okay, so let's solve it. X minus 93 is 1.6. X minus 93 is negative 1.6. Okay, then we add on both sides. This gives me 94.6 million. That's the max. Okay, this one gives me 91.4 million. That's the min. Okay, so that means in inequality form, I'll show you what it means in inequality. That means, right, because the sun just doesn't go 91, 96, 91, 96, or whatever. It varies from between 91.4 million and 94.6 million, right? There's a variance. So there's some kind of like implicit inequality built in there. All right, let's take a look at one more. I got one more for you to try. Leona was in a golf tournament last week. All of her 4 rounds of golf, were within 2 strokes of par. If par was 72, what are the maximum and minimum scores that Leona could have made in the golf tournament? So take a second, pause the video, pick out the given information, okay? And then when you have all that and you've solved it, unpause, and I'll show you how to solve. Okay, so what do we need to know? 2 strokes of par. Par was 72. So let's think about the keywords here. Within. When you see like that, what that tells you is that's going to be the number that goes on the other side, because the difference is within 2, at most 2, okay? So I'll actually do this as both. So I know that the difference between the score and par is 2, but if you think about within, it really feels like you're supposed to do an inequality. The reason that we're doing an equation is because it specifically uses the words maximum and minimum. But what if we looked at it also as an inequality? Let's see what the different answers would be. So here, I split x minus 72 is equal to 2. I don't know why I'm getting some blurriness going on here. Let's see if I can resharpen that. Beautiful. And x minus 72 equals negative 2. So I solve, I get x equals 74. I solve, I get x equals 70. And if you think about it, that makes sense, right? If I'm within 2 of par, then the most I could have scored would have been 74. And the least I could have scored would be 70, right? Because those 2 numbers are within 2 of par. But think about it. If I'm within 2 of par, I could have scored 71, 72, I could have hit par, 73, or 74. So there's actually a range. And when you solve these kinds of problems, what helps is if you actually think in your head, what sort of values could I have gotten based on the situation? And that's what I just did out loud, okay? So let's try it with the inequality. So again, bars are alone. X minus 72 less than 2. X minus 72 greater than or equal to negative 2. Okay, so either x is less than or equal to 74, and then you've got x is greater than or equal to 70. Okay, so what that means is that x is more than or equal to 70, it's at least 70, and less than or equal to 74. Okay, so that's how we solve absolute value equations, and a little bit of a taste of how do we solve absolute value inequalities. Okay, so again, I really encourage you, and I know we're getting to like the 15-minute mark, but I really encourage you to go back and take a look at all of the stuff that I've done with these 4 absolute value word problems. There is absolute value word problems in the review packet, and I encourage you to take a deep dive into those, especially if you're struggling. And I also encourage you to come in for extra help if you want me to maybe generate some problems for you to solve as well. Okay, so here's what I'm going to do. I'm going to go ahead and I'm going to move on. And I'm going to talk about absolute value inequalities word problems. Now, I did get this sheet, as you can tell, from an online source. And what I'm going to do is I'm going to try to link in the description both of these worksheets. So if you want to do these worksheets on your own, or you want to have these worksheets to do along with me, feel free to do that. Okay? So what I like about this worksheet is it actually kind of gives you a really nice explanation about how do you set these up. So these are inequalities specifically. So let me show you how this kind of setup works. Pretend that you're allowed to go within 9 of the speed limit of 65. So look at for these key words. The key words give you a good sense of where things are supposed to fit in when you solve these. If you note, there's only 2 numbers in these, right? They give you a 9, they give you a 65. You only have to put 2 numbers in before you solve it. Okay? So what you got to ask yourself is, where do the 2 numbers go? That's probably the harder part. So I really, really, really recommend you underline for success on this. So I'm allowed to go within 9 miles of 65 without getting a ticket. Write an absolute value inequality that models the situation, and write the inequality by solving that shows the speed you can go without a ticket. What's nice about this sheet is it's actually explained to you how do you set it up. Okay? So notice the difference between how fast I'm going and the speed limit can be no more than 9, meaning I can go, and it actually has to be less specifically. So I cannot go, and this should really be an or equal to, I feel. So I can go up to 9 miles over or 9 miles under. So here's what I recommend. This is what you do in your head. Ask myself, well, how fast am I allowed to go? Well, I got to go within 9. So if I went 9 over, I'd be at 74, right? Because that's 9 above it. If I go 9 under, I'm going to be at 56. So what does this mean? What this means is that in your answer, these need to be in your answer, because we know from using our intuition that that is what the situation means. Okay, so if I had flipped these numbers, x minus 9 is less than or equal to 65. Watch, I'll show you what would have happened if I flipped these numbers around. This is like the wrong way to do it. So when you get Barcelona, you get x minus 9. Okay, so look what happens when I try to solve this. Here, it looks like it's working. Watch this one now. Right? Uh-oh, that's already a negative. So if I add 9 to negative 65, I'd be at negative 56. Negative 56, not positive 56. That's not good. That doesn't make sense. How could you be going negative 56 miles an hour? So that's what you're going to get. One, you're going to get answers that don't work, and you're probably going to get answers that don't even make sense. Let's see the ones that do make sense. So what if I split it up the right way? So I get x minus 65 and less than or equal to 9. Now, this does look negative, but let's solve it out. So here you get x is less than or equal to 74. Here you get x is greater than or equal to 56. Now remember, this is an and, so you really should tie it back together in the end. So 56 is less than or equal to x, which is less than or equal to 74, okay? Meaning I can go as low as 56 or as high as 74. In the problem, they technically didn't have the or equal to, so if you didn't have an or equal to, it would be the same, except you just wouldn't put or equal to right there. Okay, so if you need a second to understand how I did that, I encourage you to go back and look at that. Otherwise, I am going to move on to the next problem. All right. I'm going to use my covering up paper again, so we stay focused. All right. In a poll of 100 people, Misty's approval rating as a dog is 78% rather, with a 3% of error. Error, meaning variance of 3%. Write an absolute value inequality that models the situation and solve the inequality. I'm going to solve it. I'm not going to convert to a decimal. You could if you wanted to, but here's what I'm going to do. 3% of error. So if you've ever seen like a poll, right, you'll hear a margin of error, 5%. What that means is that the actual numbers could be 5% higher or 5% lower than what you're seeing, which means that the difference between what it actually is and what the poll is indicating to us is at most 3%. So let's think about it. If I was 3% off, that means I could actually be as high as 81%, but I could also be as low as 75%. So those answers have to be, the range has to indicate that in the final answer. And let's see if it does. So I have x minus 78% is less than or equal to 3%, and x minus 78% is greater than or equal. And I know you're saying, Mr. Murray, negative 3% doesn't make sense, but we aren't done. So let's give it a chance for a second. So if I add 78% on both sides, I get x less than or equal to 81%. Here, if I add it on both sides, I get x is greater than or equal to 75%. So my final answer is 75% is less than or equal to x is less than or equal to 81%. I'll slide that over there so you can see it. Okay, so again, we split it. Less than 3, greater than negative 3. We get x alone, and we come in here for our final number. Okay? So what is this telling us? Remember, this is what we're expecting to have, so this is what we should have. So go in there and start by asking yourself in context, what does it mean? What am I supposed to get? And then in the end, your answer needs to agree with that. Okay, I'm going to now come down to this, and this is going to be a you try. And I know we got a lot of football fans out there. So according to the NFL rules, a football used in a game must have an air pressure of 13 psi plus or minus 0.5. Write an absolute value inequality that models the range of the acceptable air pressure, then solve. Notice it specifically asks us for an absolute value inequality. So here's what I want you to do. I want you to take a second. I want you to pause the video. The first thing I want you to ask yourself, what values, if it's got to be 13 plus or minus 0.5 psi, what values could the football weigh? I mean, what could the air pressure be, I guess? So what could the air pressure be if that's true? What's the highest, what's the lowest? Think about it in your head in context. Then I want you to make an absolute value inequality and then solve it. So again, pause the video and do these three things. 1, using the situation, figure out in context what is the actual highest and lowest air pressure based on the situation. 2, write your absolute value inequality. And 3, solve and ensure that the highest and lowest that you determined is actually what the range represents. Okay, so go ahead and pause your video now. All right, here we go. So what we know is it's got to be 13 psi plus or minus a half psi, which means it could be as high as 13.5 psi and as low as 12.5 psi. Okay. So now that means that our inequality, we have to have this 13.5 be the top number and the 12.5 be the bottom number. So again, we set up, and these are included. That's why I put or equal to, because it could be 13.5. That's okay. It could be 12.5. That's okay. So the or equal to is fine. So the difference between the PSI when you actually do the football pressure and 13 has to be no more than 0.5. So again, the difference between the actual pressure and 13 is no more than 0.5. So it's good to put it into words. Now I split it. x minus 13 less than 0.5, x minus 13 greater than or equal to negative 0.5. Okay, we add 13 on both sides. We get less than or equal to 13.5. We get greater than or equal to 12.5. We wrap it together, put it in a little Christmas gift or holiday gift, whatever you prefer, like a Hanukkah gift. Okay, 12.5 is less than or equal to x, is less than or equal to 13.5. Check it with the context. Is that true? Is my football supposed to be more than 12, at least 12.5 psi and less than 13.5 or equal to 13.5 psi? Yes. So that's why it's helpful to start in the beginning thinking about the context. What should my max and min of the range be? Is that what I get in the end? If you'd flipped these numbers around, you would have gotten, one of them would have been right. The 13.5 would have been right. But then the other one would have been like negative 12.5. So you get an answer that doesn't make sense. Also, think about the numbers, right? You can't have a negative percent in this case. You can't have a negative pressure. You can't have a negative speed. So think about that when you're thinking about the problems, because then if you get answers that don't make sense, it means you need to go and fix your intervals or fix what you're doing, okay? So again, if this was tough for you, go back, go through it again, and then in a moment, I'll move on to the final problem. All right, so here's the final problem. For the last 20 years, Mr. Bean has weighed 120 pounds, give or take 4 pounds. Write a compound inequality representing all possible weights for Mr. Bean. And the compound inequality is going to come from an absolute value. So I'm going to just annotate that, absolute value inequality. Okay? So again, go ahead. First, ask yourself, given the context, how much? What's the most Mr. Bean has weighed? What's the least Mr. Bean has weighed? 2, come up with an absolute value inequality based on the context. 3, solve the absolute value inequality and ensure that it agrees with your numbers from step 1. Okay, so go ahead, pause, do those 3 things, and then in a moment, unpause, and I'll go ahead and show you how to solve. All right, here we go. So example 4, he has weighed 120, give or take 4, meaning the most he could have weighed is 124 pounds if he had been more, because give or take means within 4. The least he could have weighed is 116, okay, because that would be minus 4. So now we have to ask ourselves, but here's what I love about this. They really kill you with the past 20 years. That's not relevant. And I know you see a number, you think, all right, the 20's got to make sense. That one doesn't matter. That's why I actually like this one a lot, because they hit you with that irrelevant information. So what now goes in here? So this is his weight. The difference between his actual weight and 120 is no more than 4. Okay, so we split it. X minus 120 less than or equal to 4. X minus 120 greater than or equal to negative 4. Now we add 120 on both sides, so x is less than or equal to 124. We add 120 here. X is greater than or equal to 116. We see 2 positive numbers. That's a very good sign. We wrap it. 116 is less than or equal to x, which is less than or equal to 124. We go back and ask ourselves, is that true? If he's been 120, give or take 4, does that mean his weight has been between 116 and 124? Yes, it does. Okay? So folks, absolute value inequality word problems and equation word problems are not easy. And you know what? I feel that solving the actual ones without the word problems is not easy either. But it takes a very diligent thought process to be able to do this. You got to ask yourself, 1, what numbers make sense in the context? 2, what is the thing that I'm trying to hit? 120 pounds, 13 psi. what is the actual acceptable range? So I'll just come up and show you this picture again. I actually really like how they set this up. So what is the thing that I'm talking about? It's within how much of what desired value? Within 0.5 of 13 psi, within 4 pounds of 120 pounds, within 9 miles per hour of 65 miles per hour. So once you have that set up, the rest of it is solving inequalities, absolute value, just like you always have. Okay, so please keep the questions coming. I thank you for watching this video. I know it's not easy to watch these long videos, but I appreciate your persistence. I appreciate your tenacity and really sticking this through, and I hope it makes a difference. And remember, you can do it. All right, so keep the questions coming, keep seeking out the help, and you can do it, folks. Have a wonderful day.